going to be looking at two physics problems. Let's start with question 1. Let's walk through this collision problem together. We've got two identical 10-kilogram pucks. Puck A, which is seen here, is moving east at 30 meters per second. And puck B is just sitting there. They collide and stick together and move as one object afterwards. So here's how we figure out what happens next. First, I look at momentum because momentum is conserved in any collision. So I calculate the total momentum before the collision. Only puck A is moving, so the momentum is its mass times its velocity. 10 kilograms times 30 meters per second. And all is moving towards east. It does not change. Now they stick together, so the total mass afterwards is 10 plus 10, which is 20 kilograms, which is seen here. Since momentum has to stay the same, I set the total momentum equal to the combined masses times their final velocity. So I divide 300 by 20, and that gives me 15 meters per second east. Now, let's check if the kinetic energy is conserved. Since they stick together, I already suspect this is an inelastic collision, which usually loses some kinetic energy. So I calculate the kinetic energy before the collision. That's 1/2 times the mass times the velocity squared. 1/2 times 10 times 30 squared. That comes out to 4,500 joules, which is seen here. After the collision, the combined objects moved at 15 meters per second. So now I do 1/2 times the new mass times 20 times 15 squared. That gives me 2,250 joules, which is seen here. Question 2. A boy kicks a football at 20 meters per second at a 30-degree angle. We're going to find how long the ball stays in the air, how far it travels, and how high it goes. Here's a little diagram demonstrating that. At any time we launch something at an angle, the first step is to split the velocity into horizontal and vertical parts, which is seen here. Now to find time in the air. The ball starts on the ground and lands on the ground, so we can use the formula for time of flight, which is seen here. So the ball stays in the air for a little over 2 seconds. I used the 2 here, the initial velocity that is seen here, and then multiplied it by 0.5, and then used gravity, which is 9.8, which is always given, and got 2.04 seconds. Now to solve the horizontal distance. Velocity never changes because we're ignoring air resistance, which we could use this equation for. Here we will use 20, which is the initial speed, seen here as well, and multiplied it by the cos of 30, which is the launch angle, which is seen here. Then we plug it in here, and since we found time originally here, which is 2.04 seconds, we can plug it into our equation here, and then we multiply it all together to get 35.3 meters. We're using the cos instead of sine because it's the horizontal distance, this distance. Now to find the maximum height, we look at only the vertical motion, which is this, and we use this equation. Here we could use the velocity given for the y, and then you square it by 2, and then we do 2 times gravity, and we get 100 divided by 19.6 to get a maximum height of